All right, great job. And now let's move on to example two. We're going to talk about compositions with inverse functions. So my big hints here, work from the inside out. And remember, if you're doing any arc, anything, to keep in mind the restrictions. Again, cosine and is in quadrants 1 and 2, and tangent and sine are in quadrant 1 and 4. So keep those in mind because they're going to rear their ugly heads probably in this example somewhere. All right, so let's start at 2a. If I'm looking at 2a, I see the arc tangent of negative root 3. Arc meaning whose angle has a tangent of negative root 3. Obviously, we're talking quadrant 4 because this is a tangent who's negative. So if I want to see who has a tangent of negative root 3, I'm just going to talk about a quadrant 4 angle who has a tangent of root 3. So again, I'm going to go to my hand. Tangent is, sine over cosine or bottom over top. So I need root 3, meaning I need 3 fingers showing on the bottom. And there's my good friend pi over 3, who seems to be almost every answer in this example. But we will move on. It is pi over 3. So we are talking about a 60-degree angle, but in quadrant 4. So we are talking negative pi over 3. Now we at least know what angle they want to discuss. So I can tell you now that we want to know what is the sine of negative pi over 3. Or in other words, down in quadrant 4, the reference angle is pi over 3. Could you tell me the sine? And so yes, back to my hand, pi over 3. I'm going to fold you down. And your sine is root 3 over 2. And there's your answer. Whoa, wait a minute. All students take calculus. That we said was in quadrant 4, where sine should be negative. So the actual answer is negative root 3 over 2. So I can go back here and tell you the final answer to the sine is negative root 3 over 2. Remember to work inside out, starting first here, and then finally answering the question. And the question was sine, meaning give me the opposite over the hypotenuse. And there we go. All right, look at B. A lot of people think, hey, look, cosine and arc cosine, they cancel each other out. And for sometimes that is true, but you got to be very careful that when you're doing an arc cosine, you're only talking about quadrants 1 and 2. Look at that angle, 5 pi over 3. I don't think that's in quadrant 2. In fact, I know it's not. It's got to be in quadrant 3. I'm sorry, 4, because it's almost 2 pi. 6 pi over 3 would be 2 pi. That's just a pi over 3 short. So, in essence, pay attention, stay on your toes. So cosine of 5 pi over 3, well, cosine, that's just saying, hey, figure it out and you should be able to tell me the angle. Cosine, not arc cosine, because I'm working on the inside of the parentheses, working here. They're saying, hey, go to 5 pi over 3 and tell me the cosine. So again, I got to think of reference angle. Reference angle is definitely pi over 3, but be careful, it's in quadrant 4. So now when I go down here, reference angle is pi over 3. We're going to fold that down. And his cosine is going to be root 1 over 2, or 1 over 2, a half. So now that I know it's a half, I can go back and figure out the rest of the problem. I know that this is really asking me who has an arc cosine of 1/2. Now notice that in quadrant 4, we had to remember all students take calculus that cosine was positive. So that's why I didn't put negative 1/2 as the ratio. Now the next part of the question, who has a cosine of 1/2? So that's what arc cosine is saying. It's saying go back and tell me what angle has a cosine of 1/2. Now you would think it was just 5 pi over 3, but because this is arc cosine, we're restricted to quadrants 1 and 2. So who the heck in quadrants 1 and 2 would have a cosine of 1/2? It's obviously not 2 because it's not negative. So therefore, I'm only looking in quadrant 1. Who has a cosine of 1/2? Back to my hand, cosine of the top fingers. I'm going to fold this one down. There's my 1/2. And I know that the answer is pi over 3. That is the finger I pulled down. So finally I got pi over 3. So again, be super careful where you are and make sure you're paying attention to if it's an arc cosine or a regular cosine and what they're actually asking. When I ask you for cosine, I'm asking you to give me a relationship of adjacent over hypotenuse. But when I'm asking you for arc cosine, I'm asking you what angle has that relationship, and you're supposed to tell me an angle. All right, see you in a few.